Kia ora koutou, aku Taura. In this video lesson, we're going to be going over Patai Tuarua, the second question of your mock exam. All right, so we are told here, households that are found to use excess water of more than 63,000 liters would be charged a fee. A Water Infrastructure and Environment Committee estimated the amount of water used over 90 days can be modeled by a normal distribution with a mean of 48,600 liters and a standard deviation of 13,500. Based on this model, what proportion of households will use between 40,000 liters and 60,000 liters in a 90-day period? So setting up our normal distribution curve with the mean value, 48,600 being here in the middle, and putting in our endpoints. 40,000 would, of course, be below it, and 60,000 would be above. First thing we want to do is convert those x values into z values. The 40,000 translates into negative 0.637, and the 60,000 into 0.844. Looking up those in the table, we can see that a 0.637 Z value has a 0.238 probability, and a Z value of 0.844 has a probability of 0.3007. Because we want both of those, they add those together, and we get 0.5387 for your achieved mark. Next one, part 2. Of the 111,979 households, how many would be expected to use excess water? Now with this Patai, this is where drawing the curve is so important, because if we wanted to see how many will be using excess water, that's going to be above the 63,000 liter marks. That's why I shaded that part in there. Changing 63,000 to a Z value, we get 1.067. Looking up 1.067 in the table, I get 0.357. Well, this is not the region we're looking for. We want the part on the other side of that. So we subtract the 0.357 from 0.5, giving us a probability of 0.143 of using excess water. Take that and times it by the 111,979 households, and we get 16,012 and 9.997. You can round that to 16,013. Correct answer only for achieved, the full thing with the working for a merit. Next, we are told that in reality, 20% of all Christchurch households use excess water. If this statement in the online news article is true and the mean or average water use is in fact 48,600 liters, what should the standard deviation be? So in other words, we know that the excess water probability is 0.20. Well, if that's 0.20, in between that, back to the mean will be 0.3, because everything above the mean has to be 50% or 0.5. So using our formula, where Z is x minus mu over sigma, we know the Z value is 0.841. We know that the x was the 63,000, the mean 48,600, so the only thing that's left is the standard deviation. We rearrange this equation to make sigma the subject, and we get 17,122 liters. That would be for your merit. Getting the Z value, that will be your achieved, or a correct answer would get you your achieved. Now, based on that above answer, comment on the suitability of a normal distribution. Well, we know that almost all the data is within 3 standard deviations. So if 48,600 is my mean, then I subtract 1 standard deviation, I get 31,478. If I do that again, going to negative 2 standard deviations below the mean, 14,356. If I do that again, my third standard deviation below the mean gives me negative 2,766. So therefore, the normal distribution is not suitable because it results in our third standard deviation below the mean being negative, which is not possible. You're not going to have negative water use. Okay, last one, or next one. We're looking at this, commenting on the relevance of water usage by looking at the shape, center, and spread, and whether or not it's suitable for a normal distribution. Well, one thing about a normal distribution is it's a bell shape. This is not bell shaped. So talking about the shape, simply not bell curve shaped, not suitable for the normal distribution. Now the center. Since there are 51 data points in here, 7, 16, and 12, now right around here, that's going to be where the median is. When we've got a normal distribution, the mean, the median, and the mode are right in the center. So here the peak was between 200 and 400, where the mean was between 400 and 600. So central value not at the peak. Again, a normal distribution is not what we're looking for here. And the same thing with the spread. If our standard deviation is 476 and we start backing up from the mean, we again have negative values, which just simply does not make sense when it comes to liters per day. So it is again not suitable for a normal distribution. Moving on, since this data is from all of New Zealand and could include rural areas, it may not reflect Christchurch's water usage. Last year, the histogram was winter water use, and I highlighted that winter daily usage. One thing I would think would be true that summer water use is going to be a lot higher, so a winter water use table might not be appropriate for the whole year, and therefore might not give a whole year representation for Christchurch. Okay, any problems, let me know. I'll be back with question 3 in our next video lesson. Thanks for watching. Maori mahi, maori ora, ka kite ano.